Welcome to Lesson 2, Triangle Midsegments. Our objectives are to identify properties of triangle midsegments and to use these properties to help to solve problems. Okay, let's look at what is a midsegment. The definition of a midsegment of a triangle, which is sometimes called the midline, is a segment that joins the midpoints of two sides of a triangle. Notice these congruency marks in red. Since DC has the same congruency mark here as DA, that means that this green line, this midsegment, has bisected this line. In other words, it is a point of line AC. Same with this side here, CB. Notice the two congruency marks compared to the two. That means that this portion, CE, is congruent to the bottom portion, EB. So again, this midsegment is bisecting CB, or it is at the midpoint of CB. Let's look at the triangle midsegment theorem. The theorem says if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half as long. So in other words, DE is parallel to AB. DE is also going to be exactly half of AB. It's half as long. All right, if D right here is the midpoint of CA, which it is, you can tell by the congruency marks, and E right here is the midpoint of CB, again you can tell that's the midpoint because of the two congruency marks, then DE is parallel, this is parallel to AB, and DE is 1/2 of AB. So that's just what we were saying. We're going to look at an example. We're going to prove that given this triangle here on the next slide. What we've done is we've taken a triangle, put it on the coordinate plane, and we have put in a midpoint. And I'll prove to you that that's a midpoint. And we're also going to then prove that these two lines, DE and AB, are parallel. So let's go ahead and look at step 1. How do we know that DE is the midpoint? Well, we know how to use the midpoint formula. In fact, we've just recently used it. So to figure out if D is the midpoint of CA, we need to find the coordinates of C and the coordinates of A and find the average of the x's and the average of the y's. Well, if we do that, we get 2, 3, and that's where D is. If we do the same thing for E here and we find the average of our C and B coordinates, we get 3, 0, which is right here. So we have now proved that DE is in fact bisecting, or the midpoint, of these two legs of the triangle. Let's look at step 2. Now we want to show that the midsegment is parallel to AB. That's going to be important when we start looking at parallel lines and properties of angles on parallel lines. So if we want to show that DE is parallel to AB, then all we need to know is that their slopes are the same. Remember that two lines are parallel if their slopes are the same. So we need to find the slope of DE, and we need to find the slope of AB. And here we do that. We do rise over run, and we get a slope of -3. And for AB, we also do rise over run, and we get a slope of -3. Okay, so now we know that the slopes are the same, so the two lines are parallel. Let's move on to the last step. We also said in this theorem that DE is 1/2 of AB. If that holds true, then we can solve a lot of missing links knowing that. Well, in order to determine that DE is half of AB, we're going to use our distance formula, which we've also recently used. And so if we use the distance formula, remember it's really just Pythagorean theorem that's rewritten as, instead of c squared equals a squared plus b squared, it's c equals the square root of a squared plus b squared. So we find the distance of DE, and we find it to be root 10. We find the distance of AB, and we find it to be 2 times root 10. Well, 2 times root 10 is double root 10, so we know then that our theorem holds true. So DE is 1/2 of AB, or we can say that AB is twice the length of DE. We also have discovered that DE and AB are parallel, And all this is hinged or based on the idea that D and E are at the midpoint of the triangle legs that they intersect. Let's go ahead and look at some examples. In this triangle, QRS, T, U, and B are midpoints. So we've already discovered that these lines are hitting the midpoints of our big triangle. So now we want to know what the lengths of TU, UB, and QR are. So let's go ahead and start with TU. Well, here's TU right here. And we know then that TU is going to be parallel to RS down here. It's also going to be half the length of RS, and RS is 40. So TU is going to be equal to 40 divided by 2. So TU is just going to be 20. All right, let's move on to UB. UB is right here. And UB is going to be parallel then to QS and also equal to half the length of QS. Well, QS is 50, so UB is going to be 50 divided by 2, which is just 25. Let's move on to our final side. We want to find the length of QR. Where is QR? Well, QR now is the long length. What information do we have? Well, we have the parallel midsegment here, TB, and TB is 30. Well, we know that TB is half of QR, or we can say that QR is double the 30. So we can take 30 times 2, and that gives us 60. So we know that QR is 60. Let's look at a little more complicated example, one where we have some unknowns. In this, we want to find the value of x. So it's going to be very important to write the relationship that you know. Well, we know that this midsegment here that has a length of x minus 4 is going to be equal to half of this. Or we can say that the 17 is equal to double this. So whichever way is better for you, I'm going to write it as 17 is equal to 2 times the x minus 4. It's easier for me to work with multiplication than it is to work with division. The other way we could write this is you could say that x minus 4 is equal to 17 divided by 2, but then you're going to have to divide, or you're going to have to multiply both sides by 2 to get this out of the denominator. So let's go ahead and work with this relationship. If we have a relationship where 2 is on the outside of the parentheses, we need to distribute in order to simplify. So we would get 2x minus 8. Then we would just add 8 to both sides. And we would end up with 25 is equal to 2x. These cancel. If we divide by 2, we get 12.5. So we know that x is 12.5. We could plug x into here, and we should get half of 17, which is 8.5. And so 12.5 minus 4 is in fact 8.5. Let's look at another example. In this example, we need to find the missing variables. So let's look at what we have. We have some midsegments, and we know they're going to be midsegments because they will be marked with a congruency mark. Now, these weren't, but I know they are, so let's go ahead and mark them. Notice that I'm marking these two differently than these two and differently than these two because we don't know that all of these are the same. The only thing we know is that these points are bisecting these lines, so these lines are the midsegments of these legs of the triangle. Okay, so where do we want to start? Let's go ahead and start with Z. So again, we just need to build a relationship, and we know that this midsegment is half of the bottom. Or we can say that the bottom is twice the midsegment. So let's do that. So let's start off with 3Z minus 10 is going to be equal to 2 times the midsegment, z plus 8. So again, all we need to do is simplify, distribute the 2 and get 2z plus 16. I'm going to subtract 2z from both sides, and I'm left with just 1z or z. These now eliminate, and I'm left with 16 on the right side. I'm going to add 10, and I find that z, the variable z, is equal to 26. Okay, now what I can do is I can use the 26 to find the missing side length if I wanted to. I could take 26 plus 8 and know what this is. I could take 3 times 26 minus 10 and know what the base is. But no matter what, the base is always going to be double the midsegment. Okay, let's move on to the other variable x. So we know then that x is either 1/2 of the base here, or we know that this base is equal to double x. And again, I'm going to use that approach. So 5x minus 18 will be equal to 2 times x. I'm going to subtract 2x from both sides to simplify and solve for x. 5x minus 2x is 3x. And right now I have 0 on the right side, so I'm going to move the 18 over. And I get 3x is equal to 18. If I want to solve for x, my last step would be to divide by 3. 3 divided by 3 is 1, or 1x, and 18 divided by 3 is just 6. And again, I could take the 6, plug it in for x. I know that this midsegment here would be 6, and I actually know that the base is going to have to be 12. But you can take the 6 and plug it in. 5 times 6 is 30. 30 minus 18 is 12. And that is our lesson on triangle midsegments. So as long as you understand the relationship between the midsegment and the line that's parallel to it, you will be able to solve problems.